The price of a car in Canadian dollars is approximately $23,460. What is the price of 12 cars? Consider significant digits. The actual calculation for this question is pretty simple. The total price would be the number of cars times the price for each car, which is $23,460. This becomes $281,520. However, can we trust all of these digits? Are these all significant digits? To answer that, we have to look at the significant digits in the original problem. There are two numbers in this problem, $23,460. This is an approximate number. Therefore, we can consider the question of significant digits for this number. Since the last digit is 0, there are only 4 significant digits in this number. So 23,460 has 4 significant digits. The other number in this problem is 12. 12 cars. This is an exact number, 12 cars. Therefore, there are an infinite number of significant digits in here. Let's explain it this way. Would you expect that with a more modern measuring device, somebody at some point would be able to find that the number of cars is 12.1? We know this is impossible. The number of cars is either 12 or 13 or 11. But it can never be 12.1. It is not a continuous quantity, it's a discrete quantity, the number of cars. You may say that maybe the number of cars was 13. If the number of cars was 13 and not 12, then there is a mistake in measuring involved here. There is difference between mistake and error. The concept of significant digits considers the concept of error, which is something in a measurement. For example, the length of a rod could be 12.1 inches or 12.15 inches, depending on what measuring device you use. But the number of cars can never be 12.1. It's either 12 or 13 or 11. And if somebody by mistake says that instead of, let's say, 13 cars, you had 12 cars, we don't consider the concept of significant digits in this case, because there is no error involved. What is involved is a mistake which is out of our consideration. In other words, we know that when we say there are 12 cars, there are for sure 12.00000 and so on cars. In other words, all of the digits are known. We know that after the decimal point there is a 0, and after that decimal point there is another 0. We are sure, because by no measuring device at some point it would turn out that one of these quantities 0.00000 would turn out to be something other than 0. So there are an infinite number of significant digits in this number. Or in other words, it's an exact number. So exact and infinite number of significant digits are the same. What is the lowest number of significant digits in our problem? There are two numbers. One of them has infinite number of significant digits. The other one has only 4 significant digits. The final answer, therefore, must have 4 significant digits. Therefore, the total price is $281,520, only 4 significant digits, and that means that the total price is approximately $28,150.